Hope the PPT is now visible to you all. Someone please respond. Is the PPT visible to you?
Yes, sir.
Okay, right. We are going to discuss about electrical distribution automation. The term distribution is the key here. Electrical power is, electrical energy is a form of energy which is very convenient among all other forms of energy we come across. Because any available form or many available forms can be conveniently converted into electricity, and electricity can be conveniently converted into any required form. That is why we are all interested in electricity and various aspects, issues, etc. associated with electrical energy. If we notice, if we want sound, we can produce sound by using electricity. If we want heat, we can generate heat by using electricity. If we want light, we can generate light by using electricity. If not electricity, if we want to have all those forms of energy in our day-to-day life, it is really a laborious process to meet those requirements. Because the form which we require, the form of energy which we require, may be available at a distant place. We may need heat. For an example, by combustion of coal, we can get heat. But coal is available somewhere in Talcher or so. Heat is required in Vijayawada. How do we complete the activity of obtaining heat out of coal? We have to transport coal from coal fields, Orissa, either by railways or roadways. We have to arrange a combustion arrangement in the local requirement zone. We need to make use of all that, and we have to then finally get the heat. So transportation itself needs considerable amount of time, few days. But you take an induction cooker or a water heater or a microwave oven. How are you getting the heat in those devices? Just by tapping a switch on, you are able to get the heat in very fraction of seconds. What is the input to all these devices? You are getting the heat out. Electricity. Where is it? It is available at your premises through a network. What is that network? Why are we preferring this? Though electricity is generated at a distant place, the supply system, which includes transmission and distribution, makes it lightning fast for the end user to use electricity for his different varieties of applications. It's very fast in transferring electricity from one place to another place. That is what I mean to say. So the place where electricity is generated is called power generating station or main station. And the places where various consumers of electricity are located are called load centers. Again, loads may be categorized on different bases. That is what we are going to discuss in due course of time. Now, the electricity generated at the generating station, which is usually far away from the load centers, must be connected to load centers by some means. The means by which the main stations or the generating stations are connected to load centers is called power supply system. So the power supply system includes transmission and distribution of electrical power. Transmission is done at high voltage. The power generated at the station is stepped up to a higher value of voltage. The reason for stepping up to a higher voltage is when power is transmitted at high voltage, the losses in the line will be less because the increased voltage for the same power makes the current in the line to be reduced. The lesser value of current in the line makes the loss in the line to be less. So usually we use a substation or transformer at the generating station to increase the voltage level to a higher value. And we run the lines for several hundreds of kilometers. And when the power has to be distributed among various locations where loads are situated, the lines will be diversing to various locations. All the process involves a lot of mechanism like transmission lines, substations, distribution lines. And we are very much focused on distribution systems. What do you mean by distribution? At a larger scale, if you want to understand supply system, transmission can be divided into primary transmission and secondary transmission. Distribution can also be divided as primary distribution and secondary distribution. Secondary distribution is usually at direct usable voltage of normal low voltage consumers, where the electricity is supplied in India for three phase at 450 volts and for single phase at 230 volts, maintaining the frequency at 50 cycles per second. So the primary distribution and secondary distribution has a huge network. To be more understanding and more simple, if you observe an electricity pole close to your house or on the way to your house, if you observe the number of connections of pole, it will be very clumsy. There will be too many service mains drawing power from there. Too many connections. It will be like a mad hub. Now, to ensure electricity at the consumer premises with quality, what do you mean by quality here? We need the voltage at the required promised level, and we need the frequency also to maintain at the required level. So when we distribute electricity to various consumers who may have a variety of loads in their premises, the individual consumer will be affecting the operation of loads or the quality of power supply available at his premises, not only at his premises, but also at the premises of other loads connected onto the same feeder. This is all you might have studied in your undergraduate level, where the distribution system is taken for primary and secondary distribution. Distributors, feeders, and service mains are the actual lines that we find in a distribution network. So distribution is the actual lines or the setup of actual lines that distribute, by the name itself, it says that distribute electricity to various types of consumers. Now, once electricity is distributed to various consumers, apart from ensuring quality of supply at each consumer premises, for whatever electricity a consumer use, how is a particular consumer connected to the distribution network? For making arrangements and for completing all the establishment required to distribute electricity among various consumers, and to maintain the quality of power supply at the consumer premises, there will be a lot of cost involved by the way of purchasing electricity from generating station via transmission corporations and establishment of distribution network, various substations. All these things need a lot of exercise. This needs a lot of revenue. This needs a lot of investment put in. So who has to bear all the financial burden in this regard? Finally, the consumer who is actually in need of that electricity has to bear all the financial burden with respect to the distribution network. So the consumer has to be charged for the electricity he consumes. How to charge the consumers is again a question. There may be an industry which has crores of rupees turnover, and there will be some domestic consumers who will be using very minimal loads like fans and lights. We cannot treat both these cases same in charging for what they consume at their premises. There should be a differentiation between the consumers of such nature, such diversified nature. Therefore, the loads should be monitored regularly. The loads has to be categorized and the system has to be established to meet all these requirements. In order to understand all these things, we proceed further. Like any other course, electrical distribution automation, to be understood clearly, to be learned, needs some prerequisites. We need the basic idea of electrical power distribution system. We have to know what is a feeder, what is a distributor, what are service mains, what is active power, what is reactive power, what is power factor, what is the size of feeder, what is the size of distributor, what is the size of service mains, all these things. We need to know various types of distribution arrangements also, like radial distribution system and ring main distribution system. We should also have an idea of distributors which are fed from one end, that are fed from both ends. When they are fed from both ends, what is the voltage maintained at the two ends is also an important point to be considered. Then compensation in electrical distribution systems, which you have already studied in UG level, is also a prerequisite to understand electrical distribution automation. What is the compensation mechanisms, or what is compensation in electrical distribution system? One should know. Then we need a basic circuit analysis concepts to analyze various distribution networks, the current flows and voltage drops, etc. to be analyzed. We need knowledge of circuit analysis. We should also have load modeling concepts. Modeling of loads analysis is also required for understanding electrical power distribution automation. Then, what are the objectives of these generating stations? Am I audible? Is there any disturbance in the network?
Yes, sir.
No, sir, audible.
No, sir. No, sir.
Okay.
Is it
If
audible?
there
Audible?
is if there is any disturbance due to network issues, you please just call me. You have my number, right?
Yes, sir.
Okay. So the objectives of going through all these automation concepts is to learn the importance of economic distribution of electrical energy. See, distribution of electrical energy is not just the issue here. Being an electrical engineering student, you may be having a knowledge of distribution of electrical energy, but being a practicing electrical engineer, we must be conscious about the economical aspects. What is the cost involved? How less we can spend in the particular distribution network of electrical energy. So these are the concepts we are going to learn in this course, electrical distribution automation. Then voltage drop is quite common issue in distribution networks because of the load variations on feeder. There will be voltage drop in the other loads connected. And eventually there will be a loss of power in the line. So then what are the losses? How to calculate the loss? How to calculate the reactive power? How to calculate the voltage drop? All these issues are to be learned. How to analyze a distribution network for evaluation of voltage drops, power loss, calculation of active and reactive powers. Then protection is one more important aspect of distribution network. There are common problems that may cause interruption in power supply to consumers. Can we stay at home with disconnected electrical supply for 2 hours? We cannot imagine that. We are so much habituated to enjoy the electricity at our home for various reasons. If we are out of service for 1 hour at least, we cannot digest that. So to foresee the possibility of a problem in the distribution network and to execute preventive mechanism to arrest the possible problem, or in case of unavoidable problem, the system that has to bring the lines back to the service are all very important. So this needs a proper protection mechanism. So we need to understand the coordination among all the protection devices that are used in electrical distribution networks. Then capacitive compensation and voltage control. These two are the very important problems, very important aspects when the quality of power is concerned. Capacitive compensation. Most of the loads, industrial, domestic, agricultural, etc., are inductive loads. You know that inductive loads makes the power factor to be very poor. And it will be economical for the system if we can ensure the power factor to be unity. So the best alternative to ensure the power factor to be unity is using capacitive banks. That is called capacitive compensation. And this will also address the control of voltage problems. Then to understand the principle of voltage, what is voltage control, what are the principles of voltage control will also be studied in this course. Then let us consider the first unit. First unit is mostly a general idea of distribution systems. Introduction to distribution system. What is distribution? What are different types of distributors? What is radial distributor? What is ring distributor? All these aspects will be discussed in the introduction part. Then an overview of role of computers in distribution system, planning, load modeling, and characteristics. We know load curves, load duration curves. We know various important aspects that determine the system operation, design, and control. We know graphical and mathematical evaluation in UG level, but here you need to understand role of computers in distribution system, how to plan it, how to model it, how to characterize the loads, and how to study the load characteristics. We know various factors when it comes to distribution systems. Average load, maximum demand, connected load, load factor, demand factor, diversity factor, utilization factor, plant capacity factor, diversity factor, coincidence factor, contribution factor, and loss factor. So all these factors and associated definitions are essential in evaluating the economic aspects of generating station. As we are in a plan of utilizing computer-based simulation and modeling, we should have the basic knowledge of all these concepts. Then relationship between load factor and the loss factor will also be discussed. Classification of loads. As I have already mentioned, we need to discuss what are residential loads, what are commercial loads, agricultural loads, industrial loads, urban traction loads, municipal loads. There are a variety of loads which we have studied in the UG level itself. And we'll take their characteristics like load characteristics. Load curves may be daily load curves, weekly load curves, or monthly load curves. Based on the time we consider on x-axis, maybe hours in a day, days in a week, days in a month, or an year. We call them as daily load curve, weekly load curve, monthly load curve, and annual load curve. So we study the characteristics for a variety of loads to understand application of computer systems in analyzing all these factors. So this is what we are going to deal in the first unit. We try to finish it in 1 or 2 classes. What is the book that you have used in UG level to learn distribution systems?